to introduce our first speaker today, Anastasia Gogi from Loughborough University. She's going to talk to us about the value of discrete event simulation at Jerry Insights.
Yes, thank you very much for introducing me. Today I'm going to present you part of our ongoing research. My supervisors are Ella and Stuart. And more specifically, I'm going to present you how we conduct an experiment in order to evaluate the value of discrete event simulation in generating insight. Now, the presentation I have divided into 4 parts. First, I'm going to talk about the purpose of this study, and then I will overview some aspects of the experiment we recently conducted, and that will bring me to discuss some results of pilot runs, and I'll leave you with our next steps. Now, to kick off with the purpose of this study, well, discrete event simulation is a technique that usually is seen as a hardware technique, but our focus is on its softer sides, and more specifically, we want to investigate how simulation users move from partially understanding to fully understanding the problem, and therefore generate new ideas, maybe intuitively, on how to address and improve the performance of a system. So this rather descriptive definition of our aim has a name in the creative cognitive psychology, and this is the process of insight. Now, to explain you a little bit better what is insight and how psychologists use the term, let's assume that this is me, and someone gave me a problem and a task, let's say. And so I know where I am now, and I know where I want to be. And recently I conducted relevant work, so I'm quite confident that I can solve this problem. So the first thing that I do is to apply my knowledge, but I realized that no, this wasn't the right way to approach the problem, and I don't have any clue how to solve the problem. So I enter in an impasse phase. From there, I don't know how to move on. But all of a sudden, or intuitively, I got an idea. And I'm very happy because I know now how to approach the problem, and I know that it will be a leap because it will take me out of the impasse phase, it will bring me directly to the solution. So this is the process of insight, and this is what we want to investigate. And to bring that into simulation, we will know that insights occur when a simulation user suddenly knows how to improve the performance of a system after several failed attempts, after several what-if scenarios. So the process of insight involves doing something wrong and then consciously understanding the mistake and correct it. Now, to give you some examples of mistake people usually do, so usually people misjudge options, misevaluate options. So to generate insights, they have to change their attitude, their initial beliefs to the right direction. Another mistake that people usually do is to fix their mind on one way of doing things, and without understanding that this way cannot address their problem. So to generate insights, they have to overcome this implicitly imposed constraint of doing with one way of doing the things, and to find other ways. So why we believe that discrete event simulation can support insight generation? Well, basically because of the methodologies that have been proposed to support the modeling process, but also because of the visual interactive simulation and the visual interactive modeling features that have been added in almost all simulation packages. So to create a model is a very easy rapid process, and you can interact with the model and change it whenever is needed. Now the problem is that in the discrete event simulation literature we don't find enough evidence of this kind of use, because usually academics and practitioners prefer to report how they solve the model instead of actually reporting how the model helped people to solve their problem. And from findings in experimental studies that have been conducted in SD literature, the findings show that people face difficulties in understanding and predicting the behavior of a system. Now, from the few empirical findings, evidence in the discrete event simulation literature, it is not transparent how, what was the factor that helped people to generate insight. It was the model, the modeling process, or other factors. So we focus on the model in this study, and we want to determine how the use of discrete event simulation support users in generating insights. So we want to provide some empirical evidence. And we want also to establish how the animation and statistical features of visual interactive modeling simulation contribute to insight generation in order to use better the model. Now, to put formally, two hypotheses we make here: that insights will be generated more frequently by the use of a simulation model, and second, that the contribution of animation to the process of insight will differ from the contribution of statistical outcomes. Now, to address our objectives, we thought that it would be a good idea to conduct an experiment. An experiment allows us to isolate factors, and also the task of the experiment, we can replicate it so we can have a large sample size. But to conduct an experiment successfully, we had to think carefully a lot of aspects, from the independent and dependent variables to the participants, the procedure, and the task, and the model. I'm going briefly now to overview these aspects. So participants were divided into three groups, two experimental and one control. So one group, participants in one group were using the animation of simulation, participants in another group were using statistical results generating from a run of the model, and one group had no simulation, so they had to use their own problem-solving skills to solve the same problem. Now, the participants, we decided to use students because students do not have prior experience and knowledge, so we expected that they will be adventurous and they will take risk and freely experiment with the model. So we also, because we wanted a representative sample, we used incentives, monetary incentives. So each student was paid £10, and to improve their performance, we gave them a further £5 to solve if they solve the problem. So we advertised our experiment to undergraduate students doing business but no simulation modules at Loughborough University, and 47 students volunteered to participate. For the control condition, we advertised to students, undergraduate students doing simulation at Warwick University, and 20 students volunteered to participate. Now, the session was very easy, and it was the same for all groups. So we invite students in one session. We had randomly allocate to the experimental conditions, the students randomly allocate them. And they had to work individually and in silence. So we gave them a case study, they read it, then they had to submit a brief answer what the problem is there, and then they had 30 minutes to solve it, and at the end they submit their best scenario and a short explanation why this scenario solves the problem. At this stage of the session details, the experimental groups had to load the model, and they were instructed to solve the problem with the model. Now the materials, what we use, the case study and the model. So we had to design an insightful task. And the insightful task, we had to design an insightful task. We had to include elements that can be easily misjudged, and the solution should involve doing something new. So, a common misjudgment in business is that hiring inexpert and cheap staff supported by few professionals could be cheaper, maybe better than hiring only professionals. So our case study was based around a new telephone service, the NHS 111, which is a call center for non-emergency healthcare. And basically the service is manned by operators who are supported by medical advisors. Now we gave them the case study, so we told them about the structure of the service, we told them about the cost and the efficiency level of each type of staff, and we told them that now cannot achieve a target of a budget and a time limit, and they had to solve the problem if they were the managers to solve this problem. So the model, the experimental group had to use a model that looked like that. So the group that were using animation had this model. So they had to change here 3 parameters: the number of operators, nurses, and doctors. And they just ran the model, and at the end, they got here the result of their scenario. And the statistics, the group that were using statistics, had the same model. The animation was switched off, but they will get more information about the performance of their scenario. Now, the novelty of what they had to do to solve the problem was that they had to do something new compared to how NHS 111, how the service worked up to now. So if they excluded operators from the system, as you can see, this is a winning scenario. So if they were excluded operators and they were blind, so in order to bring medical advisor closer to the patient, they will solve the problem. So now, how to measure insight? So we're using two dependent variables: the time taken to solve the problem was one independent variable, and we can measure that because we were recording the scenarios and when they set up participants the scenarios. And we also, another dependent variable was the change in attitude towards the right direction. And we measure that by the pre and post session answers that they give in the questionnaires, and also from a problem-solving pattern that we create. So to produce, I got that, I forgot. To produce that, the problem-solving pattern, we divided scenarios into 5 categories. And then the types of scenario each participant had run, we plotted in a graph over time. So scenario category 1 represents the common misjudgment. Hiring more operators is a good idea, whereas category 2 is a change, represents a change in belief. And the rest of categories involve the creativity, the divergent thinking, because involve scenarios excluding 1 or 2 types of stuff. Now, category 5, where the scenarios that we're solving the problem, we had 3 solutions, and it was a sub-category of 4. So that was our experiment, and I carried like more than 20 pilots. But when we conclude upon the materials and the session, at the end, I ran 11 final pilots. And here are the results. So the participants were friends of mine, and the age range of 25 to 30. And they volunteer to participate. And the participants who didn't have any simulation experience are just randomly allocated to the experimental conditions, and participants who knew something about simulation or they had strong analytical skills consist the control condition. Now, as you can see here, we have solvers and non-solvers in each condition. So we have 2 non-solvers in the control condition and 4 in total in the experimental conditions. Of course, we cannot conclude something about the role of simulation in insight generation, but we made some observations. So, first, we saw that simulations support problem understanding. And here I've got an example of a problem-solving pattern of a participant in the experimental condition. And as you can see, this participant didn't solve the problem because it didn't run over time scenario 5, but only scenarios 1 and 2. So he started believing that hiring more operators is a good idea, but at the end, we believe that he changed his belief because he ran scenario 2, and from his answer at the end of the experiment, that was apparent. Now, 2 out of the 4 non-solvers in the experimental conditions show that they changed their belief, whereas the 2 non-solvers of the control condition still believe that hiring more operators will be a good idea. We also made another observation that simulations support creativity and divergent thinking. And as you can see here from this problem-solving pattern, at some point, this participant decided to redesign the system. So he ran a scenario 4, which was excluding operators from the system. 3 out of the 4 non-solvers of the experimental conditions decided to run a scenario 4, so they managed to be adventurous. Whereas the non-solvers, the 2 non-solvers of the control condition, didn't thought about didn't think about redesigning the system. But the problem is that they didn't solve, so they didn't run. They didn't stick with scenarios of excluding stuff. So we believe that it wasn't a conscious understanding of the problem. So this moment of creativity stemmed from intuition rather than from consciously understanding what was the cause of the problem. And is also this apparent from another participant, problem-solving partner, who decided to exclude from the system doctors, because category scenario 3 was about excluding doctors, which is, of course, cannot address the problem. So it showed that it was an unconscious decision. Now, if a participant has consciously understand the problem, his or her problem-solving pattern may look like that. When this participant realized that a redesign of the system is an option, just need one scenario, run and solve the problem. So as you can see here is an insight must be emerged and it looks like a leap in our growth. So now to sum up our results of pilot test, we think that simulation support problem understanding because the majority of the people in the experimental condition changed their initial belief, so they learned something from this model. We also think that simulation support creativity and divergent thinking because they create new types of scenarios, so the majority of the experimental condition. But the thing is that may be not understand the problem, so these create moments may stem from intuition rather from consciously understanding what is the problem there. So our next steps, I told you that we recently conducted the experiment, so now we're in the process of analyzing our results. And our next step, because we're keen to investigate the modeling process as well, we're going to interview the consultancy team of Simulate. Thank you for your attention.